In the first phase of glycolysis, glucose enters the cell and is phosphorylated by the enzyme hexokinase, which transfers a phosphate group from ATP to the glucose molecule, making it glucose 6-phosphate. The enzyme phosphoglucosamidase transforms the molecule into its isomer, fructose 6-phosphate. The enzyme phosphofructokinase transfers a phosphate group from another ATP to the sugar, transforming it into fructose 1,6-biphosphate. The enzyme aldolase splits the molecule into two different 3-carbon sugars, dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. Only glyceraldehyde 3-phosphate is used in the next steps of glycolysis. The two sugars are each oxidized by the transfer of electrons NH+ to NAD+, forming NADH. The enzyme uses the released energy to attach a phosphate group to the oxidized substrate. The phosphate group is transferred to ADP, catalyzed by the enzyme phosphoglycokinase. The enzyme phosphoglycer mutase relocates the remaining phosphate group, and then analase, an enzyme, causes a double bond to form in the substrate by extracting a water molecule, yielding phosphoenolipyruvate. In the last step of glycolysis, the last phosphate group is transferred to ADP, forming another ATP. Overall, 2 ATP have been created and 2 pyruvates.